In this video, we're going to talk about scientific notation calculations. Specifically, our objective: perform calculations of numbers that are in scientific notation, and we're going to use Desmos to do that. As I mentioned in the previous video, scientific notation is used to prevent us from losing zeros. Really large numbers and really small numbers tend to, you tend to have zeros involved when you get to be that large or that small, and a loss of a zero results in a major change in the number. So using scientific notation helps us to not lose those zeros. So what do we know coming into this? We know what scientific notation is. It's a method of writing very large and very small numbers using powers of 10. The format for scientific notation, again, is a number, and I called it A here, times 10 to a power. Where the number in front is between 1 and 10, it can equal 1, but it's less than 10. And the exponent is an integer, -4, -3, 0, 1, 2, etc. I'm also going to introduce something else, another way to work with some of these large and small numbers. So I want to remind us that we know these popular large numbers. What you mainly see out there are numbers in the millions, billions, and trillions. Population of the US, for example, population of the world, for example, and trillions, the United States debt. Is often, I believe, is in trillions at this point. So these are the popular ones, and so let's recognize that 1 million is 1 with 6 zeros. It's also written as a power of 10. It's 10 to the 6th. 1 billion is a 1 with 9 zeros, hundreds, thousands, millions, billion. So it's 10 to the 9th, written as a power of 10. And 1 trillion has 12 zeros. As a power of 10, it's 10 to the 12th. We'll make use of that in our third example. All right, so multiplication. My recommendation here, again, we want to be aware of the order of operations when we do these things. And I recommend that we use parentheses around each scientific number. It's not required using the order of operations, but I think it's easier to see clearly. So here in example 1, we want to multiply two large numbers. 3.4 times 10 to the 9th is a very large number, and 2.15 times 10 to the 5th is also a very large number. So let's pull in our Desmos. And I think I can, I come over to here, and you can see I'm in the top left corner. Okay, and I just covered up my paper so I can't see my number. That wasn't very smart. Okay, now I can see my number. All right, so it's 3.4 times 10 to the 9th. And again, I recommend using parentheses, so we'll use the parentheses in Desmos here. 3.4, where's my times symbol? Times, and you say 10, we'll do the exponent to the 9th power. Okay. And close that one up, and then I do another parenthesis times 2.15 times 10. A to the b is the exponent to the 5th. And you can see it's already given me the answer right there, despite the fact I've not completed what I wanted to do, which is put the final parenthesis in there. And Desmos is quick. 3.4 times 10 to the 9th times 2.15 times 10 to the 5th is 7.31 times 10 to the 14th. Now this number is so large, the 14th, that Desmos is not giving it to us in standard notation or decimal notation. It's only giving it to us in scientific notation. If Desmos can write the number down in standard notation, it will do that. It just depends on the size of the number. So our answer here clearly 7.31 times 10 to the 14th. Okay, come back into here, make sure you can see it. So this is 7.31 times 10 to the 14th. And I'm not concerning ourselves with how do you actually do this by hand. We're going to make use of a calculator to do these calculations. With division, the key here again, so we follow the order of operations, is we want to use the fraction bar. Here's division. We want to first create that fraction bar and then put our numerator above it and our denominator below it. So we want to create that fraction bar first to separate the numbers. So we have here 8.4 times 10 to the negative 7th, that's quite a small number, divided by 4.0 times 10 to the negative 4th, divided by another small number. What's the answer? Well, again, let's go into Desmos. And let's make sure I can see what I've got going on here. Okay, you should see that. All right, I'll go into row 2 here, tap there, and I'll first press the division. I want my fraction bar. Okay, so it does this correctly. You notice it's highlighting the numerator. My numerator was 8.4 times 10, there's the a to b, raised to the negative 7th power. So there's my numerator. I don't need the parentheses. I'm already separating with the fraction bar. And then I'll tap on the denominator, divide by 4.0 times 10 raised to the, in this case it was a negative 4. And you can see Desmos has already given me the answer. Notice that this number is not so small. This is 21/10,000ths. That Desmos is giving that to me in standard form or decimal form, because it can do that. It's not an extremely small number. So I've got 0.0021. Okay, come back to here. And Desmos told me this is 0.0021. Now note, this is in decimal notation. If the answer has to be in scientific notation, well, we know what we need to do. We need to move that decimal to create a number between 1 and 10. So we'll move it 1, 2, 3. 2.1 is between 1 and 10. The decimal moved 3 places. So in scientific notation, 2.1 times 10, the 3rd power, but notice it's a very small number. We moved the decimal to the right to make it small. So it's a negative 3 power here to make that correct. And again, this is your scientific notation. Similarly, although you wouldn't have to do this, to write this number in decimal notation, we need to move that decimal 14 places to the right. Okay, in order to fill in all those zeros and make it large, but that's never going to get asked because that's a huge number. And most people aren't going to have that to work with. They'll work with the scientific form for this one instead. Okay, in example 3, let's look at an example that we can deal with this instead and not have to worry so much about being precise with our scientific notation. In real life, okay, in real world situations, okay, we're often told this is some billion, this is some trillion. It's often easier to simply replace million with times 10 to the 6th, billion with times 10 to the 9th, and trillion with times 10 to the 12th, and then do the math, okay? And use the power of 10, but don't concern ourselves with exact scientific notation because you don't need it in some cases. Here's an example. Example 3. As of January 2016, our country's national debt was approximately $18.9 trillion. At that time, the U.S. population was approximately 322 million people. What was the debt per citizen? Okay, so again, here we're looking for an answer that is just, how many dollars does each citizen owe, or how much, what is each citizen's piece of that? And we don't have to concern ourselves so much about scientific notation if we don't want to. So let's take a look. Debt per citizen. That word per tells us we're doing division. So debt per citizen. Okay, and we're told our debt is $18.9 trillion. I just copied this here. And we're told our number of citizens, $18.9 trillion. And our population, our number of citizens is 322 million. Okay, well, as opposed to moving the decimal or putting in all those zeros, we can just say, wait a second, trillion is 10 to the 12th. So this is 18.9 times 10 to the 12th. Million is 10 to the 6th. So I can rewrite 322 million as 322 times 10 to the 6th. Now recognize this number is written as written by multiplying it by a power of 10. It is not in scientific notation because this number is greater than 10 and this number is greater than 10. But it doesn't really matter in this case. We just want the answer. So we can keep it simple, and that's our math right here. Okay, we don't need to go and say, oh my goodness, it's not in notation, I can't do any math. Sure you can. 18.9 trillion divided by 322 million. And we can do our math. So let's go back to here. And let's make sure I can see what I've got going. Make sure you can see what I've got going. Sometimes tougher than others for me to get my screen correct. Okay. So I'll go down to row 3 in this case. Again, this is a fraction, so I'll press the division key first for the fraction bar. Okay, debt, 18.9 trillion, okay, times 10 to the 12th. There's 18.9 trillion. Divided by number of citizens is 322 million. So 322 times 10 to the 6th power, and you can see we have the answer. 58695 point, well, we've got change here, 6521739. Okay, so 58695. Okay, so Desmos told us this is 58. Make sure you can see it. 5869695. Point. They got a whole bunch of stuff here. 6521739. Okay, well this is money, debt per citizen. You know what? That's a lot of parts of pennies. We can simply say to the nearest dollar, to the nearest whole number. Okay, here's the nearest dollar. Okay, in the units place, I look to the right. The 6 will push this 5 to a 6. So to the nearest dollar, the debt per citizen is $58,696. And that's kind of what we're after here. Okay, notice I didn't have to do any changing. I just wanted this number. And so just keeping it simple, using what millions, trillions, and billions are equal to as powers of 10, and then just doing the math, and I get the answer I'm after. And sometimes that's a lot easier. So there you have it with a fair amount of scientific notation.